Hello everyone, today we're going to have a look at our lesson on exact values and solving trigonometric equations, as well as the unit circle and the four quadrants. So the idea of the unit circle is telling me that I've got some sort of circle on my graph or on my Cartesian plane of radius 1. And the idea of the unit circle and trigonometry is that we're looking at, okay, if I had a random point on my circle, what would it be in terms of sine, cos, or tan? Now, if I have a random point xy, and I want to know, okay, if I drew a triangle like I've done in black, what would the values of x and y be, such as the ones I've drawn in red? Well, if I call the angle theta, I know that sine theta, which is opposite over hypotenuse, would be y over 1. Now, the reason the hypotenuse of this triangle is 1 is because this is a unit circle, and that's a circle with radius 1. So no matter where I am on this circle, my radius is always 1. Now, if we wanted to look at cosine, cos of theta, it's adjacent x over hypotenuse 1. So what that has told us is that the point xy along a unit circle becomes cos theta sine theta. And that's because the value of x is now cos theta and the value of y is now sine theta. Now that's going to be very, very important. And it's going to introduce the idea of all stations to central. All stations to central. So the idea of all stations to central helps us understand whether sine, cos, and tan are positive or negative. Now I know that 0 degrees is here, and if I went up here, I would be at 90 degrees. If I went over here, I'd be at 180 degrees. And if I went down here, I would be at 270 degrees. Now we also know these are called quadrants. This is quadrant 1, this is quadrant 2. This is quadrant 3, and this is quadrant 4. Now in the first quadrant, both x and y are positive, and that's what the all in all stations to central mean. Both x and y are positive. So since we've just said that x was cos theta and y was sine theta, then we're going to say both sine theta, cos theta, and we're also going to say tan theta are all positive in the first quadrant. Now in the second quadrant, we're going in the negative x direction, but in the positive y direction. So we've got negative x's, but positive y's. And that's what stations stands for. It's telling us that only my y's are positive, only my sine is positive. We've defined y to be sine of theta. So my sine is positive, but my cos is negative, and also my tan is negative. Now the reason tan is either negative or positive isn't in the Year 9 course, but for those who are interested, it's because tan is equal to sine over cos. But for now, you just need to accept that tan is negative in the second quadrant. Now in the third quadrant, we've got negative x's and negative y's. So we're going to say both sine and cos are negative. And because those two are negative, it actually makes tan positive. So tan, and that's what 2 stands for in all stations to central. Tan is positive in the third quadrant, the other 2 are negative. Finally, in the fourth quadrant, I've got positive x's, so positive cos, and negative y. So I'm going in the negative y direction, so I've got negative sine. And that's what central stands for. So what that is telling us is that only cos is positive in the fourth quadrant, the other 2 are negative. So to recap that, in the first quadrant, sine, cos, and tan are all positive. That's what the A stands for. In the second quadrant, only sine is positive. In the third quadrant, only tan is positive. And in the fourth, only cos is positive. Now we're going to put that to one side and have a look at something called exact value triangles. So there are three very special triangles. Number one is this isosceles right-angled triangle. Number two is our 30-60 triangle. And number three, this is a very strange triangle. It's actually impossible to have this triangle. However, it helps us visualize some important concepts. So this triangle helps us understand exact values. Now I'm going to paste in a table from one of my lessons. Hopefully that pastes in. Maybe not. Okay, I'll just have to draw it myself. So the idea of exact values in trigonometry extends from our calculator's ability to do certain concepts. So when you type in, for example, cos of 30 in your calculator, you will get 0.866. Now, we know that when we solve questions in Pythagoras' theorem and we're asked for things in exact value form, then that means we want it in surd form. Now, your calculator is not the best and it can't do some things in surd form, which is why these triangles are important, because they help us find these funny decimals such as 0.866 being the root 3 on 2. If you type in sine of 45, you'll get 0.707, which is actually 1 over the square root of 2. Now, if we have a look at these triangles, let's look at angle 0 degrees, which is up here. We know sine is opposite over hypotenuse, 0 over 1. Cos is adjacent over hypotenuse, 1 over 1. And tan is opposite over adjacent, 0 over 1. If we try a 30-degree triangle, I've drawn that triangle 1. That's a 1 and that's a 2. Our 30 degrees, well, sine of 30 degrees, I've drawn it wrong again. That's a 1 there and that's a 2 there. Sine of 30 degrees is going to be opposite over hypotenuse, 1 over 2. Cos of 30 is adjacent over hypotenuse, root 3 on 2. And tan of 30 degrees is opposite over adjacent. Now we can keep going. We can keep filling these in. And we're going to get this special table here. And this is what we call our exact value table. Now I'm going to stop when I get right here. Because if we have a look at tan of 90, we get opposite over adjacent, 1 over 0. And we're not allowed to divide by 0, so we say it's undefined. So tan of 90, if you type it into your calculator, you will get maths error. So we say it's infinite or undefined. Now you're not expected to memorize this table, because in exams you will be given these three triangles. However, it is understood that we can get this entire table from these three triangles. Now, often you won't actually be given this triangle, namely because it's an impossible triangle. We can't have 0 degrees and a 0 length and make a triangle. That doesn't make any sense. However, you can get all of the 0 degree ones on your calculator, as well as the 90 degree ones, because they don't have any surds in them. Let's tie that together. So find the exact value of cos of 60 will be our first example. We're going to, yes, we've got the table, but we're going to practice using our triangle. We look at our 60 degrees. Now cos is adjacent, 1 over hypotenuse 2. 1 over 2. Part B, sine of 150. Now we're going to pause sine of 150. We're going to pause here for a second, and we're going to go back to the reason we learnt about all stations to central. So we've said that, well, first of all, we're all positive in the first quadrant. In the second quadrant, only sine is positive. In the third, only tan is positive. And in the fourth, only cos is positive. But we also know that, let's say all angles in the first quadrant, let's call them theta. Now in the second quadrant, we're going to call this our 180 minus theta quadrant. we're going to call our third our 180 plus theta quadrant, and our fourth our 360 minus theta quadrant. Now, I could go and explain, and I'm going to briefly explain why these are the case. I'm not going to do it fully, but if we just want to have a think about this, all angles in the first quadrant, yep, we're just going to call it theta. Now in the second quadrant, we know that all angles add to 180 degrees along a straight line. So if this was a theta here, in here would be 180 minus theta, and that would get my angle in there. So this quadrant is 180 minus theta. If I want this angle here, well, it's going to be 180 plus an extra theta. And if I want this angle here, well, it's the same as going all the way around by 360 and then taking off theta. That's why those are the case. So when we do questions such as finding the exact value of sine of 150, we are not going to use our calculator. Using a calculator for these questions often shows that you don't fully understand what is happening. And especially when we're solving trig equations, if you're using your calculator to solve these, it's only ever going to give you one out of the two possible solutions. So I'm going to draw my all stations to central over here. This is theta, this is 180 minus theta, 180 plus theta, and 360 minus theta. We're going to practice finding something we call the related acute angle. So we don't like, when we're finding exact values, we don't like obtuse or reflex angles. So we're going to figure out what is an angle that is the same as 150 degrees. To do that, we're going to ask ourselves what quadrant is 150 degrees in. And it's in quadrant 2. So quadrant 2 is our 180 minus theta quadrant. So we're going to ask ourselves, 150 plus what is 180? And that would be 30. So we're going to say sine of 150 is the same as sine of 30. We then have to consider what quadrant I'm in. 150 degrees is in the second quadrant. In the second quadrant, sine is positive. So we're all good here. Sine is positive, we don't need to do anything because it's already positive. We then look at our triangle to find sine of 30. Sine is opposite over hypotenuse, 1 over 2. Example number 3, I'm going to copy this and bring it back down. Example number 3, we're going to look at tan of 135. Well, we're trying to think, okay, what is my related acute angle? We don't like having obtuse answers or reflex angles. So we're going to ask ourselves, what quadrant is 135 degrees in? And that answer is the second quadrant again. The second quadrant is our 180 minus theta quadrant. So we're going to ask ourselves, 135 plus what is 180? And that's 45 degrees. 180 plus 45 is 180. Pardon me, 135 plus 45 is 180. Now this is where it gets different. We know that in the second quadrant, 135 degrees is definitely in the second quadrant. But we know only sine is positive in the second quadrant. It says it here, stations. Only sine is positive. That's telling us tan is negative in the second quadrant. So we're going to put a minus there. Now if we go up to our exact value triangle, tan of 45 is opposite over adjacent, 1 over 1. But we've got a negative out the front, so the answer is minus 1. Part D, we might have a look at cos of 210 degrees. Well, we're going to ask ourselves, right, what quadrant is 210 degrees in? Well, it can't be the first, it's too big. It can't be the second, it's more than 180. And it can't be the fourth because it's not quite bigger than 270. So it has to be in the third, which is our 180 plus quadrant. So what we're asking ourselves is 180 plus what? is 210. And that's 30 degrees. So we're going to say this is cos of 30 degrees. But we've just said that 210 is in the third quadrant. In the third quadrant, only tan, it's all stations 2 for tan, is positive. So that's telling me cos is negative. Now, if we look at our graph, cos of 30 is adjacent over hypotenuse, root 3 on 2. Now again, if you type in cos of 210 into your calculator, it's going to give you minus 0.866, blah, blah, blah. There's no way of you knowing that's root 3 on 2, and at this level of maths, it's not good enough to write 0.866. We need to write root 3 on 2, especially if it asks for exact values. Now, this idea of exact values and different quadrants goes into the idea of solving trigonometric equations. So let's say I were solving the equation 2 sine of x is equal to root 3. Well, in year 8 and year 7, we've experienced how to solve one-step equations and 2 and 3-step equations and so on. So we're going to apply that ability to trigonometry, and we're going to make sine of x the subject by dividing both sides by 2. So that tells us that sine of x is root 3 on 2. Now, this is a question we're finding an unknown angle, and it's going to be the unknown angle x. To do that, we're just doing inverse sine of root 3 on 2. And if you do that, you get 60 degrees. However, as I've said in class many times, all trigonometric equations have two answers. If you just give me one answer, it's not good enough because there's always two answers. When we do these questions, once I've got my acute angle, we need to ask ourselves, okay, root 3 on 2, is that a positive or a negative number? Of course, we know, again, I've said it's 0.866, a positive number. So we have to think, right, where is sine positive? Well, obviously the first quadrant, but also the second quadrant. That's because our stations, the S stands for sine being positive. The reason we're looking for positive sine is because root 3 on 2 is a positive number. Now the second quadrant tells us 180 minus, so we're going 180 minus 60. So x is 60 degrees or 120 degrees. If you type in sine of 60 or sine of 120 into your calculator, both of them will give you root 3 on 2 or 0.866. Okay, example 3, we're going to solve sine of x is equal to, actually we might do cos of x is equal to a half. So again, we don't have to do much here because cos of x is already the subject. So we just need to say x is not tan, cos inverse of 1 over 2. You just have to do that on your calculator. Cos inverse of 1 on 2, you get 60 degrees. But remember, trigonometric equations always have two solutions. Every single time, they never have one solution. Actually, that's not true. They can have one solution if we do something called restricting the domain, but we're not going to worry about that in year 9. So in year 9, they always have two solutions. So we've got 60 degrees, and that's because cos is positive in the first quadrant. Now we're going to look at, okay, is the number 1 on 2, 0.5, is it positive or negative? Of course, it's a positive number. So we have to ask ourselves, where is cos positive? It's positive in the first, but also the fourth quadrant. That's our central. C stands for cos. So we're going 360 minus 60. 360 minus theta is our fourth quadrant. So our two answers are 360 and 300 degrees. Now these answers, they don't have to be exact. We don't have to have nice, beautiful 60 degrees, 300 degrees. We can have approximations as well and rounding. So if we had tan of x is equal to 1 on 10, well, of course, our first step is to go inverse tan of 1 on 10. And we just type that into our calculator, 1 on 10. And if you do that, you get 5 degrees 43 minutes. After we've done that, again, remember trigonometric equations have two solutions. We have to think, okay, what is my second answer going to be? The number 1 on 10 is a positive number, so we know we're looking for where is 10 positive. We know 10 is positive in the first quadrant, all of them are positive in the first quadrant, but we also know it's positive in the third quadrant, and the third quadrant tells us 180 plus. If we do that, we get 5 degrees 43 minutes and 185 degrees 43 minutes. Those are my two solutions there. Last one for this video, we need to consider, right, what if I instead had some negatives? So tan of, let's change it up, alpha, we can make it whatever we want. Tan of alpha is minus root 3. As I've said in class many times, we never ever type in the negative into our calculator. So we're never going to do this, tan inverse of minus root 3. Please never do that. I'm going to show you why we don't do that in a second. So for now, we just type in positive tan inverse of root 3. Tan inverse root 3, type it into your calculator, you get 60 degrees. Now this is our acute answer. But we need to consider our two quadrants that we're in. So we think of our all stations 2 central, and we have to ask ourselves, tan of alpha in the question, it's no longer positive, it's a negative number. So we only care about the quadrants for which tan is negative. And that's the second, because sine is positive there, and the fourth, because cos is positive there. Tan is not negative anywhere else. So those two quadrants are our 180 minus theta quadrant and our 360 minus theta quadrant. So our answers are 120 degrees and 300 degrees. So same idea as before, except instead of considering where it's positive, we have to consider where it's negative. As you're doing these questions, remember all trigonometric equations, every single one of them, will have two solutions. So if you don't have the second solution, you're not going to be able to access full marks on a question like this. The main important part of this question is that we never type in tan inverse of negative root 3. The reason we do that, I don't do that, is because if you type in tan inverse, I'm going to do it right now, negative root 3, it will give you either 120 degrees, it might also, depending on what calculator you have, give you minus 60 degrees, or it might even give you 300 degrees. If it gives you 120 degrees, or if it gives you 300, it's going to make it much more difficult to find the second answer. But if you just type in positive root 3, it's going to give you 60 degrees every time, and it's very easy to find the two solutions. All right, thank you for listening.